The James Webb Space Telescope has just helped uncover something so strange that it sounds almost impossible. A mysterious object from the early universe that looks something like a star, but may actually be powered by a gigantic black hole. Astronomers are calling it a black hole star. And if their interpretation is correct, this object could help solve one of the biggest mysteries in modern astronomy. How did enormous supermassive black holes appear so incredibly early in the history of the universe? The newly studied object is called MOM-BH Star 1. And the light reaching the James Webb Space Telescope today began its journey when the universe was less than about 660 million years old. Think about that. The universe today is roughly 13.8 billion years old. So James Webb isn't simply looking far away. It's effectively looking backward in time, capturing ancient light that has traveled across the cosmos for billions of years. And hidden inside that ancient light, astronomers found something they didn't expect. To understand why this discovery is so important, we first need to understand a mystery that James Webb created almost as soon as it began observing the distant universe. Scientists started noticing tiny, compact objects in Webb's images. They became known as little red dots. The name doesn't sound particularly exciting, but these little red dots have become one of the biggest puzzles in astronomy. They appear in the young universe. They're extremely compact. They're unusually bright. And many of them don't behave exactly the way astronomers expected young galaxies to behave. At first, researchers considered several explanations. Maybe they were extremely dense young galaxies. Maybe enormous numbers of stars were forming inside them. Maybe dust was changing their appearance. Or maybe something much more extreme was happening. Black holes. But even that explanation created another problem. The black holes appeared to be growing far too quickly. Normally, we imagine a black hole forming after a massive star reaches the end of its life. The star collapses. A black hole remains. Then, over enormous amounts of time, that black hole can grow by consuming gas, swallowing matter and merging with other black holes. Eventually, some can become supermassive black holes containing millions, or even billions of times the mass of our Sun. There's just one problem. James Webb keeps finding evidence of massive black holes extremely early in cosmic history. Almost too early. It's like walking into a forest filled with enormous ancient trees, and then discovering that the forest was planted yesterday. Something seems to be missing from the story. How did the universe build these monsters so quickly? That's where MOM-BH Star 1 becomes fascinating. Researchers studying the object found that a normal star simply doesn't appear capable of explaining the amount of energy we're seeing. Instead, their modeling points toward a much stranger possibility. At the center could be a rapidly feeding black hole. But surrounding that black hole is an enormous, dense envelope of gas. That gas absorbs and reprocesses energy produced by material falling toward the black hole. Instead of looking exactly like the black holes astronomers normally observe, the entire structure can take on characteristics that resemble an enormous red star. Hence the strange name. A black hole star. But don't imagine a normal star like our Sun, with a black hole somehow sitting inside it. This would be something radically different. The black hole would be the engine. Matter falling toward it would release tremendous amounts of energy. Then an enormous cocoon of gas surrounding the black hole would absorb and transform that radiation before allowing it to escape into space. From billions of light years away, James Webb detects the resulting light. And that light contains clues. Astronomers can separate it into a spectrum, almost like splitting white light into a rainbow. Different atoms and physical processes leave different signatures in that spectrum. Hydrogen leaves clues. Helium leaves clues. The motion of gas leaves clues. The temperature leaves clues. And when researchers studied these characteristics, they found that an ordinary collection of stars struggled to explain what they were seeing. A black hole surrounded by an enormous amount of gas provided a much more interesting explanation. The central black hole in Mom BH star 1 may have a mass on the order of 100,000 suns. That's already enormous. But remember when we're seeing it, less than about 660 million years after the Big Bang. In cosmic terms, that's extremely early, and the entire surrounding structure could be vastly larger than an ordinary star. This gives scientists a potential missing link. Maybe some of the universe's earliest massive black holes didn't begin as relatively small black holes and slowly grow over billions of years. Maybe nature had a shortcut. Under the right conditions in the early universe, enormous concentrations of gas could collapse and create very massive black hole seeds. Those seeds could then grow rapidly. Surround them with huge amounts of dense gas, and you could produce objects that look like these mysterious red dots Webb keeps detecting. Eventually, the gas surrounding them could disperse. The black hole could continue growing. Galaxies could form and evolve around them. And billions of years later, their descendants could become the supermassive black holes we find at the centers of giant galaxies, including the kind of black hole sitting at the center of our own Milky Way. And here's where this story gets even more interesting. Mom BH star 1 isn't the only evidence pointing in this direction. Earlier Webb observations have produced strong evidence that at least some little red dots are rapidly growing black holes hidden inside dense cocoons of gas. One particularly important object is known as Glimpse 17775. James Webb captured an extraordinarily detailed spectrum of this little red dot. Scientists found multiple features consistent with a rapidly accreting black hole surrounded by dense gas. So Mom BH star 1 isn't appearing in isolation. It's becoming part of a larger pattern. Webb may be revealing an entire population of objects that astronomers couldn't properly see before. And that is exactly what makes the James Webb Space Telescope so powerful. Webb observes primarily in infrared light. As the universe expands, light traveling across enormous cosmic distances gets stretched toward longer wavelengths. This effect is known as redshift. The farther back into the early universe astronomers look, the more important infrared observations become. Webb was specifically designed to explore this ancient universe. And ever since it began science operations, it has repeatedly found objects that challenge our expectations about how quickly cosmic structures formed. Galaxies appear surprisingly developed. Black holes appear surprisingly massive. And the early universe increasingly looks like a much more active and complicated place than scientists once imagined. But there's something very important to remember. Science doesn't work by finding one strange object and immediately declaring the mystery solved. Researchers test competing explanations. They build models. They compare predictions with observations. They gather better spectra. They search for similar objects. And sometimes the explanation that initially looks strongest eventually turns out to be wrong. That's why scientists are still investigating exactly what these little red dots are. Some researchers have proposed alternative models involving enormous stars. Others favor rapidly growing black holes. It's even possible that the objects we group together as little red dots don't all have exactly the same explanation. Future observations will help determine which ideas survive. But that's what makes this moment so exciting. We're watching the mystery unfold almost in real time. For decades, astronomers knew supermassive black holes existed. We know there's one at the center of the Milky Way called Sagittarius A star. Its mass is roughly 4 million times that of our Sun. Other galaxies contain black holes hundreds of millions or billions of times the Sun's mass. But explaining how the earliest supermassive black holes became so enormous has always been difficult. Start with a black hole left behind by a normal star, and there simply may not be enough time for it to grow into some of the monsters astronomers observe in the early universe. Start with a much larger black hole seed, however, and the problem becomes easier. Objects like Mom BH Star 1 could potentially show us one stage of that process. And there's another mind-bending part of this discovery. Mom BH Star 1 doesn't exist today exactly as James Webb sees it. We're looking at ancient light. Whatever happened to that object afterward occurred billions of years ago. It may have merged with another system. Its black hole may have grown enormously. The surrounding gas may have disappeared. Its environment may have eventually developed into something completely different. But because light has a finite speed, we're only now receiving information from that incredibly early chapter of its existence. James Webb is essentially an astronomical time machine. Not because it travels through time, but because looking farther into space means seeing progressively older light. And every time Webb pushes deeper, we're getting closer to the era when the first stars, galaxies, and massive black holes were taking shape. The telescope was launched in December of 2021. It traveled roughly 1.5 million kilometers from Earth to operate near a gravitationally stable region known as the Second Lagrange Point, or L2. Its enormous segmented mirror collects incredibly faint infrared light. And its instruments allow astronomers not only to photograph distant objects, but to analyze their chemical and physical properties. That capability is transforming astronomy. Before Webb, many of these tiny red objects were either invisible or extremely difficult to study. Now astronomers can examine their spectra and start asking what is actually producing their light. Stars? Gas? Dust? Black holes? Or combinations we've barely considered before? And that's perhaps the biggest lesson from discoveries like this. The universe doesn't have to follow the categories humans created for it. We understand stars. We understand black holes. We understand galaxies. But the early universe may have produced transitional objects that don't fit neatly into any one of those categories. A black hole star sounds contradictory because stars and black holes seem like completely different things. But the name describes an object whose appearance may be star-like while its energy source is a rapidly feeding black hole buried inside an enormous gaseous environment. And if these objects turn out to be common, astronomy textbooks may eventually need another chapter explaining how the first giant black holes were born. Researchers will now want more observations, more little red dots, more detailed spectra, more measurements of their sizes, masses, and environments. And perhaps most importantly, examples from different moments in cosmic history. If astronomers can find these objects at different stages of development, they may be able to reconstruct an evolutionary sequence. A massive seed forms. A dense gas cocoon develops around it. The black hole feeds rapidly. The system shines as a little red dot. It interacts or merges with young galaxies. Eventually, the surrounding material changes and the object begins looking more like the quasars, and active galactic nuclei astronomers already know. That's one possible story. And Webb may finally be giving scientists enough evidence to test it. So when you hear that James Webb discovered a black hole star, the real story is even more interesting than the headline. Scientists may have found evidence of a previously elusive stage in the life of the universe's earliest massive black holes. A strange object glowing across more than 13 billion years of cosmic history, carrying information from a time when the universe was still extremely young, and potentially helping answer a question astronomers have struggled with for decades. Where did the universe's first supermassive black holes come from? We don't have the complete answer yet. But James Webb may have just given scientists one of their best clues. And if these mysterious black hole stars really are the ancestors of supermassive black holes, then those tiny red dots appearing in Webb's images aren't insignificant specks at all. They could be snapshots of cosmic monsters being born. And somewhere inside that ancient red glow may be the beginning of structures that would eventually shape entire galaxies. The deeper James Webb looks, the stranger the early universe becomes. And this discovery may only be the beginning.